In this lesson, we're going to focus on finding the measure of angles with equations. Okay, this is the second day of lesson 7.1. We're focusing on parallel lines cut by a transversal where we have equations. We're still trying to find those measures. Okay, highly suggest you write this piece of information down right through here. Key piece of information, the first thing you need to do is find the relationship between the angles in which you're trying to find the measure. Congruent angles, if those angles are congruent, means they have the same measure. Both of those angles will be equal. Supplementary angles, both of those angles, that they have different measurements, and they will add up to 180 degrees. Remember, 180 degrees is what supplementary means. Okay, let's look at some examples. On this one, we have two parallel lines. We have line M and line N that are parallel, and we're trying to find the value of x. Okay, when we try to find the value of x. So first we have to go through and we have to think back to, are these angles the same or different? Think back to those definitions. Are they the same or are they different? Well, I go back to my rules and think through, okay, if I look at this angle is vertical to this one, those two would be the same. Okay, that angle, alternate interior, is going to come over there, and then vertical is over here. So these two angles are not the same. They would be different measurements because they're along a linear line. So this is a linear pair. Okay, two angles along a straight line means that those are going to add up to 180. So these angles have different measures. So add them to equal 180 degrees. Okay? So if they have different measures, we add to equal 180 degrees. So we take our x, take away 17. We're going to add that to the other measurement, which is the 5x, take away 1, and together those are going to equal 180 degrees. Okay, from here, we're back to just solving equations, which we've been doing for quite some time. First thing, we're going to collect like terms. Okay, I'm going to collect my x's. I have an x and 5x, which makes 6x. I have a negative 17 and a negative 1. Together, that's negative 18. Rewrite the equals 180. Continue to solve. I need to get that x by itself, so I need to eliminate the negative 18. And to get that to 0, I add 18 to both sides, leaving me with 6x equals 198. Now I say 6 times x. Well, I still need to get that x by itself, so I'm going to divide both sides by 6. Divide both sides by 6. X equals 33. Okay. So focusing back in on solving for x. So as far as the lesson's concerned, this is what it's asking you to do today. You're finding the value of x. Now, I would want to take this one step farther and make sure my answer was really correct. So I would come up and I would think, all right, well, if I put 33 in for x, say that top one would be 33, take away 17. 33, take away 17 is 16. So this angle would be 16 degrees. This other angle, you would take 5x, take away 1. So 5 times 33, take away 1, plug that into a calculator, and you're going to get 164. Check to make sure 164 and 16 do indeed add up to 180 degrees. Okay, this is a linear pair. two angles along a straight line. All right, let's look at another example. Okay, given that line M is parallel to line N, we need to find the value of X. Okay, so once again, we have to look at first identifying the relationship between these two angles. I see they're both parallel, cut by a transversal. So I see this one is in the lower left. This one is in the lower left. Okay, that means that these are corresponding angles. First thing you need to identify is what is the relationship between the two angles. They are corresponding. And I'm going to write that on there. So these are corresponding angles. So then thinking back, and it's a really good idea to have those definitions from lesson 7.1 beside you, where I had you write down a bunch of definitions or print those out. Those are also in Schoology in this week's folder. Knowing that corresponding angles tells us that these have equal measures. The measures of these angles are the same. Okay, so that means that I can show my work by saying, okay, 5x plus 16 is equal to 6x minus 7. These have equal measures. Okay, think back to when we were looking at all these. We said we can go, this one's the same as the vertical angle. This one's also the same as the alternate interior, which is the same as the vertical angle. That's how I know these are going to have the same measure. So if they have the same measure, we set the two angles equal to each other. Then we solve for x. Okay, in this case, I am going to subtract 5x from both sides. Remember, there's lots of ways that you can go about solving the equations as long as you are following those standard steps. Okay. So then I end up with 16 equals 1x minus 7. Then going to add 7 to both sides in order to get x by itself. 16 plus 7 is going to be 23 equals 1x. That's the same as saying 23 is x. So we know the value of x is 23, and that's what we're being asked to find on this one. Now you can take that a step farther to figure out the measure of this angle by plugging in the 23 in place of the x. Okay, so let's just do that. 6 times 23 minus 7. 6 times 23 is 138. Minus 7 is 131. So the measure of this angle is 131. To make sure that I know that I found the right value for x, I'm going to plug this in because this should be the same. 5x plus 16, replace the x with 23. 5 times 23 plus 16 is 115. Plus 16, and you get 131. Okay. And that's what we're going to do for each one of these problems today. The relationship is going to be different on each problem you're going to see. You're going to have to go back to those definitions and back to where you took some notes to identify the relationship between those angles. Okay, so let's look at another example. This one, we look at those angles. I see lower right, upper left. Okay, so I'm thinking, okay, think this one pairs with this one, because those are vertical. Over here becomes alternate interior, and then bounce over here, because remember you can go diagonal, diagonal, diagonal to find the matching ones. Okay, so those are going to be alternate interior angles. And if you look at your definition, alternate interior angles, you just scroll back to that for a second. Those definitions that you saw in the last lesson, alternate interior angles says that their measures are equal. So the measures are equal. Because we know those measures are equal, then we're going to set up our problem using our equation. We would take the 7x minus 4, make it equal to 3x plus 28. Okay, both sides, we're going to have them equal each other so that we can solve for x. Then go ahead and pause and work through this one and then press play once you think you've solved for x. Okay, I'm going to subtract 3x from both sides to move all my x's to one side. I have 4x minus 4 equals 28. Add 4 to both sides. 4x equals 32. Divide both sides by 4. X is going to equal 8. Okay, that was your goal, to figure out what x equals. Now I'm going to say, I'm going to go ahead and plug that in because I like to make sure that I'm right. 7 times 8, take away 4. 56, take away 4, 52. So I found that this angle is 52 degrees. Go over here, take my 3x plus 28, take my 8, 3 times 8 plus 28. 3 times 8 is 24 plus 28. I do get 52. So this angle is also 52. Okay, so if this angle is 52, this angle is 52. That means this angle would be 52. This angle would be 52. Okay, now we could figure out the measure of the other angles just because we're in here and we're playing. So if this angle is 52, this angle over here has to be what? Well, together, because they're going to be a linear pair along that straight line, that means they have to add up to 180. So I could take 180, take away 52, and figure out that this angle is 128. So remember I said as long as you know one angle, you can find all the other angles in the two parallel lines cut by a transversal. Okay, so then this angle over here is also going to be 128 because they're vertical angles. Then I can say that this one over here is 128 because of alternate interior angles. And then this one was going to be 128 because they are vertical. Okay, so look, there's lots of information, so many ways that we can prove that these angles are correct. These two, 52 and 128, are along that straight line, so they're a linear pair. Over here, 128 and 52 are along a straight line, so they're a linear pair. This way, another straight line, linear pair. Notice these two also add up to 180 because they're consecutive interior angles. These two over here also add up to 180 because they're consecutive interior angles. Over here, also, notice not a place on here are the 52s next to each other. Okay, that's the way this works. They're going to be supplementary every direction that we look. All right, go ahead and work through the problems for today. Make sure you message me if you have any questions or concerns or need any extra help.